where the data cannot be collected through the machines, through the scale. So there the data can be collected through assigning the rank. So that is why it is called as Spearman's rank correlation coefficient. When the repetitive ranks is given, the formula is different. When the ranks is not given, we have to figure out the ranks. How to take up the deviation? R1 minus R2. So that is your rank 1 minus rank 2. Hello everybody, I'm Divya, lecturing Vidhyaashram Pre-University College, Mysuru, the Temple of Excellence. Today I take this opportunity to welcome you all, a hearty welcome to the session 3 on your chapter 6 correlation. So in the last class, we have discussed about the Karl-Pearson's coefficient of correlation, the problems of Karl-Pearson's coefficient of correlation, and the formula we have discussed in the last class. In today's class, we will be discussing about Spearman rank correlation coefficient. So, the topics for today's discussion: Spearman's rank correlation, calculation of rank correlation, and the conclusion. Moving forward, so before understanding, let us understand first what a Spearman's rank correlation is all about. Spearman rank correlation was developed by the British psychologist C. Spearman. So that is why they have kept the name Spearman rank correlation. So to find out the relationship between two variables, so they provide the rank. They rank the variables, and based on the rank, they find out the relationship. So such kind of technique that is there to measure the correlation, that is Spearman's rank correlation. The Spearman rank correlation formula is 1 minus 6 sigma d square divided by n cube minus n. So what does this n stands for? N is nothing but the number of observations. Suppose 1 to 10 data is given, so the number of observation will be 10. Suppose the data 1 to 6 is given, the number of observation will be 6. So what is this D? D stands for deviation. So while understanding the problem in a better way, we'll understand the formula as well. Moving forward, when is the Spearman rank correlation used? Why the Spearman rank correlation is used? Because we have other two techniques that we have discussed in the previous class. That is your scatter diagram and as well as your Karl-Pearson's coefficient of correlation. So why is this Spearman's rank correlation coefficient is put into your subject so that you will be able to understand in this slide? It is used in the following situation. So when it is used, suppose we are trying to estimate the correlation between the height and weight of students in a remote village where neither measuring rods or nor weighing machines are available. So if you want to get the data in a rural place, so neither the measuring rod or neither the height and the measuring weighing machines are available. In such a situation, we cannot measure the heights and weight. So with the weighing machine, we weigh the weight and tell what is the weight of a student. So by using the scale, the height of a student can be provided, but neither the weighing machine nor the scale to weigh nor the scale to check out the height is available in the rural place. In such a situation, when the data cannot be collected, so what kind of thing can be done? So in such a situation, we cannot measure the height or weight, but we can certainly rank the students. So from there, what they did, they started ranking the students. Ranking is nothing but putting in an order, 1, 2, 3, 4. So that is an order. They rank the students. So certainly, according to weight and height, they started ranking the students. So these rank can then be used to calculate the Spearman's rank correlation coefficient. So in the word itself says, it is called as what? Spearman's rank correlation coefficient. So based on the rank, they find out the relationship between the two variables, x and y variable. That is your In that way, you will calculate your correlation coefficient. So, Spearsman, who is a Spearsman? See, a Spearsman is a psychologist. C is Spearsman. So, he has developed this rank correlation coefficient, and this is the formula of Spearsman's rank correlation. So, why the name they have given as rank correlation coefficient? Because where there the data cannot be collected through the machines, through the scale, so there the data can be collected through assigning the rank. So that is why it is called as Spearsman's rank correlation coefficient. Moving forward, we'll understand why again the Spearsman's rank, in which case the Spearsman's rank correlation coefficient can be used. Suppose we are dealing with things such as fairness, honesty or beauty. So when it comes to honesty, beauty and fairness, these are the characteristics. So what are they? They are characteristics which cannot be expressed in qualitative, which cannot be expressed in quantitative. It has to be expressed in qualitative form. So that is your word form. That is your characteristics which will be expressed, such as fairness, honesty, beauty. So these cannot be measured in the same way as we measure the income, height, weight, because that is quantitative. Here it is qualitative data. So at most time, these things can be measured relatively by using the rank. So they rank the people according to the beauty, according to their honesty and according to their fairness. So some people would argue that even this is not possible because standards and criteria of beauty may differ from person to person and the culture to culture. So if we wish to do that, in order to know the relationship between the two variables such as your beauty kind and the characteristics, the attributes, then we use rank and then assign the ranks to that, and then we find out the relationship between two variables. This is the second situation where rank will be used. Third situation, Spearsman's rank correlation coefficient can be used in some cases where there is relation whose direction is clear, but it is non-linear as shown in the scatter diagram. So for this case also, ranks will be assigned, and then with the help of that ranks, you will be able to calculate the relationship between the two variables. Moving forward, calculation of rank correlation. So it can be calculated under three cases. So three situations. First situation is the ranks are given. The second situation, when the ranks are not given, so with the help of that data itself, we have to find out the ranks. And the third case is, or the third situation is what? Ranks are repeated. So ranks will not be the same. It will be repetitive in nature. So how to solve the problems under these three cases, that we'll look after in today's class. Moving forward, case 1, when the ranks are given. So the rank itself will be given in the question itself. So you have to read out the questions carefully, my dear students. Why? Because in the question itself, ranks will be mentioned. So when the ranks will be mentioned, the format that we follow to calculate the problem is different. So when the repetitive ranks is given, the formula is different. When the ranks is not given, we have to figure out the ranks. So you have to read out the question carefully and find out whether the ranks are given in the question or not. So when the ranks are given, so this is how we solve. So let us look into some practical problems. So this is very important for your examination. So let us understand the question. 5 persons are assessed by 3 judges. So how many judges are there? 3 judges are there in a beauty competition. So we have to find out which pair of judge has the nearest approach to the common perception of the beauty. So what is the beauty? What perception these judges have? Since there is 3 persons, we need to calculate 3 different format and then calculate which is what is the relationship we have. So what perception do the similar judges have? That is A and B. So this is very important question. So 3 judges are there, 5 contestants are there. So we have to calculate which judge, A or B or C. So which judge has a nearest beauty perception towards each other. So we have to compute that. So This is the data given. So judge A, judge B and judge C. So as I have told you, since 3 judges are there and the 5 contestants are there, we have to calculate thrice. 3 times has to be calculated and find out the calculation. I find out the rank for all the 3 judges, and we have to see which judge has the nearest beauty perception. So we have competitors. 5 are the contestants. They are the competitors who are participating in the beauty contest. So these are the ranks given. So already the ranks has been given. So A judge has given 1, 2, 3, 4 and 5. B judge has given 2, 4, 1, 5 and 3. And C judge has given 1, 3, 5, 2 and 4. So what is this? These are nothing but the ranks they have already given in the question. So in the question itself you can see 5 persons are assessed. They have already assessed by 3 judges in a beauty contest and they have given the ranks in the question. So you have to calculate the rank correlation using Spearman's rank correlation coefficient and find out the answer. The formula will be Spearman's rank correlation is equal to 1 minus 6 sigma d square divided by n cube minus n. So this is the formula that we have to follow. This is your series given. There are 3 pairs of judges necessitating the calculation. So this is the formula. So we have to calculate thrice as I have told you. So we have understood the question. Now let us substitute the values. So the rank correlation between A and B is calculated as follow. So what is A data given? 1, 2, 3, 4, 5 and the B data is given as 2, 4, 1, 5 and 3. So this is the data given in the question. So how to find this deviation? So as per our formula we need deviation. So how to find out? So 1 minus 6 sigma d square divided by n cube minus n. So this is the formula. So what we require? The requirement is d square. So what is n? N stands for number of observation. So how many number of observation we have? 5 is the number of observation we have. So the A value is given and the B value is given. So how to find out this D? So R1. So this is considered as R1 and this is considered as R2. So D is equal to R1 minus R2. Rank 1 minus rank 2, you will get the deviation. So 1 minus 2 minus 1, 2 minus 4, that is minus 2, 3 minus 1, that is 2. 4 minus 5, it is minus 1 and 5 minus 3, it is 2. So if you square it, so d square, so 1 into 1 it is 1, 2 into 2 it is 4, 2 2s are 4, minus into minus plus. So you will get sigma d square as 14. So what we are doing? We are substituting the value 1 minus, so what is the 6? As it is we are writing sigma d square is how much? 14 divided by the number of observation is 5, that is 5 cube minus 5. If you substitute the value, you will get the answer 0.3. Moving forward, let us solve for the A and C. The rank correlation between A and C is calculated as follow. So in the previous slide, we have calculated for A and B, judge A and judge B. Now we are taking the comparison between judge A and judge C. So what are the ranks given? 1, 2, 3, 4, 5, that is A rank. And that has been given by judge A, and by judge C, what is the rank given? 1, 3, 5 and 2 and 4. So that is the rank given. So what is the deviation? How do you get the deviation? Rank 1 minus rank 2. So if you get this, you will get your D, that is your deviation. So 1 minus 1, 0. 2 minus 3, it is minus 1. 3 minus 5, it is minus 2, 4 minus 2, it is 2, 5 minus 4, it is 1. And the square you do, if you square up the D, so it is your D square, 0 into 0, it is 0, 1 into 1, 1, minus into minus, plus. So plus 1, 2 2s are 4, 2 2s are 4, 1 1s are 1, and the total, the summation of your D square, the total of your D square will be how much? 10. So that will be 10. So if you substitute to the formula, you will get the answer as 0.5. So what is the formula to calculate the Spearman rank correlation? R is equal to 1 minus 6 sigma d square divided by n cube minus n. So what is the number of observation we have? 5 is the number of observation we have. So 1 minus, what is the d square we have? 10. 10 6 it is 60. Divided by n cube. So what is the number of observation? 5 is the number of observation. So 5 cube. So what will be the 5 cube? So answer will be 5 into 5 into 5. It is 125. Minus 5, which is 120. So 60 divided by 120, you will get 0.5. If you subtract from 1, that is your answer will be 0.5. So similarly, you have to do it for, that's an homework for you people, my dear students. So to make you better understanding, so you need to solve the problem. So test yourself by solving the problem between Judge B and Judge C and find out the answer and tell your answers in the comment section. So the answer will be 0.9. So whether you have got 0.9, so check the answer and comment in the comment section. So let us look into the interpretation. So substituting these values, so we are comparing the beauty contest between the 3 judges A, B and C. So whose perception is similar with the other person. So we are finding the relationship. So they have given the rank. So what is the relationship we had? So in the previous problem we have, in the previous slide we have discussed about the Judge A and Judge B rank and the whatever the value we have got, and we are comparing now with Judge A and Judge C. The answer we got is 0.5. So thus the interpretation what it goes, substituting this value, the rank correlation is 0.5. Similarly, the rank correlation between the ranking of Judge B and C is 0.9. So thus the perception of Judge A and Judge B, Judge A and C are the closest judges. B and C are having different taste. So B and C judge have different taste, but A judge and B judges, they have the similar taste towards the perception of beauty. So this is how you calculate for the case 1 that is given when the ranks are given. So this is very important question. Moving forward, let us see what is case 2 is all about. So what is this case 2? When the ranks are not given in the question. So in the previous problem, judges were given and the ranks that has been allotted, rank were given in the question. But in this question, ranks are not given in the question. So let us read out the question. We are given the percentage of marks secured by 5 students in economics. So 5 students, they have scored economics, and in statistics paper, they have scored this much of marks. So then the ranking has to be worked out. The rank correlation is to be calculated. So rank is not given. So these are nothing but your marks that has been scored by the students in economics and statistics paper. So what is data given? 53, 98, 92, 81, 75, 71, 59, 55, and Y 47, 25, 32, 37, 30, 40, 39 and 45 is given. So with the help of this data, so let us substitute the value to the formula and calculate the ranks first and then find out the Spearman rank correlation. Moving forward, so let us write in a column. So X column, Y column. Let us put rank. So how to put rank? So how to rank the given set of data is nothing but which is the highest number in a given series. So the highest given number in this X series is 98. Which is the second highest number? It is 92. Which is the third highest number? 81. So likewise, we are giving rank based on the number. So in a given set of data, in a given data, so which will be the highest number in the series? So that number will be the rank 1. So rank 2, rank 3, rank 4, rank 5, rank 6, rank 7 and rank 8. Similarly, in the Y column, in a given set of data, which is the highest number? The highest number is 47. So 47, we will rank 1. We will give it as 1 ranks, first rank. The second one is 45, 40. Fourth rank is 39. Fifth rank is 37. And sixth rank is 32. Similarly, we have 30, 25 as 7th and 8th rank. So, when the rank are not assigned in the question, so you need to assign the rank. So, how to assign the rank? So, when you see the data in a given set of data, which is the highest number in a given set of data, and that number will be rank 1. So, rank wise it decreases. So, the lesser number you have to put the rank. So, highest number will be 98, less than 98 it is 92. So, you are giving second rank. So, that is how the order goes on. So, after assigning the rank 1 and rank 2, you have to find D. So, how to find D? R1 minus R2. So, if you subtract this, 8 minus 1, 7, 1 minus 8 minus 7, 2 minus 6 minus 4, 3 minus 5 minus 2, 4 minus 7 it is minus 3, 5 minus 3 is 2, 6 minus 4 that is 2, 7 minus 2 is 5. If you take up D square, if you square this number, 7 7s are 49, 7 7s are 49, minus into minus plus 49. The summation of this, the total of D square will be how much? 160. Now let us substitute the answer to the, let us substitute the values to the formula and check out what is Spearman's rank correlation value. So what is the formula? 1 minus 6 sigma d square divided by n cube minus n. So, what is the number of observation given in the data? 1, 2, 3, 4, 5, 6, 7, 8. So, 8 is the number of observation given in the data. So, 1 minus 6 sigma d square. What is 6 sigma d square? It is 160. Divided by n cube. So, what is n? Number of observation 8. 8 cube minus 8. So, if you substitute the value using a calculator, the answer you get is how much? 160 into 6, it is 960. Divided by 8 cube, 8 into 8 into 8, it is 512. Minus 8, it is 504. So, 960 divided by 504, you will get the answer as 1.904. So, if you subtract that with 1, if you minus that with 1, you get the answer 0.904. So, 0.904 is the answer that you have got. Spearman's rank correlation value, how much you got when the ranks are not assigned, we have calculated the rank. So, this is how we calculate. So, moving forward, let us understand the case 3. So, what is the case 3? The series is given, X data and Y data is given, but here it is repetitive ranks. The ranks are what? Repetitive in nature. So, here nothing is repetitive, just according to the highest frequency in a given data, we assign the rank. But here in Y series, what we will do? We will assign the ranks because the ranks are repetitive in nature. When the ranks are repetitive in nature, the formula will be this. So the formula of Spearman's rank correlation coefficient when the ranks are repetitive as the follows. So what is it? 6 sigma d square plus m. So what is this m? It is nothing but the number of observations that are repetitive in a given set of data. So m1, m2, so on m3 it goes on. So n is the number of observations. So this is how you calculate when the Spearman's rank correlation coefficient case 3 problem when the ranks are repetitive in your given set of data. So here we'll write down the data. So x value is given, so the no data is repetitive, but in y cases, how many data are repetitive? 50 is repetitive. How many times? Thrice it is repetitive. 90 it is repetitive. How many times? Twice it is repetitive. So in this kind of data, we have to solve. How to solve? Let us look at that. So we are putting ranks of x. So this is how the format that we follow. Rank of x, rank of y, deviation in marks and d square. So rank we are assigning. So which is the highest number in the given set of data, which is the highest rank. So the rank is 1200. Next is second rank, third rank, fourth rank, fifth rank, sixth rank, seventh rank, eighth rank, ninth rank, 10th rank, 11th rank, 12th ranks, because the number are in decreasing order. So they have given already according to the rank only. No data is repetitive here. So directly we are assigning the rank. So how to assign the ranks? When we have the highest number in a given set of data. So this is your rank that we have assigned for X series. And the Y series is how many repetitive we have? 50. Thrice repetitive we have 90. Twice repetitive we have. So listen to me carefully, my dear students, because here only the problem lies. So here in this case, they have given the data which is non-repetitive, but in your examination, they'll give you repetitive data for both the cases. So how to solve at that time? So what is the highest number? 100 is the highest number. So for 100, we are assigning rank 1. And what is the second number we have? The second number is 90. So how many times 90 is there? 90 is there for twice. So how many times? Twice. So which rank it stands for? Second rank and third rank. So how many times it is repetitive? Twice. So second rank and third rank. So M1 will be how much? 2 plus 3 divided by 2. So how many numbers? 1, 2. So 2 we are dividing. So 2 plus 3 divided by 2, it will be how much? 2.5 and 2.5. So that is what. And the next is 3 number is over. What is the next rank? We have 4. So what is the next highest number in a given set of data? So 85. So 85 is the fourth rank. Next we have is after 85, we have 75. We have 75 also twice given in the question. So 75, how many times? 4, rank 4 is over. Rank 4 is over. Now we have to calculate rank 5 and 6. So what is rank 5 and 6? Rank 5, rank 6. So M2, 5 plus 6 divided by 2. So 5 plus 6 divided by 2, how much it will be? 5 plus 6 divided by 2, it is 5.5 for the 5th and the 6th rank. For the 5th and the 6th rank, that is 5.5, 5.5. So 6 is over. What is the next rank we are supposed to put? 7. So what is this data after 75? What is the data? 7th rank. So we have put 7th rank. Next, after 65, it is 60. 8th rank. We have put 8th rank. Next, after 60, what is the number we have? We have 50. 8th rank, 9th rank, 10th rank and 11th rank. So M3 will be how much? 9th rank, 10th rank and 11th rank. 9th rank, 10th rank and 11th rank divided by 3. Since the number of observation, how much we have? 3. So 9 plus 10 plus 11 divided by 3, it is 10. So it is a 10th rank. So for 9th rank, 10th rank and 11th rank, your ranking is 10. Next, 11th rank is over. Up to 11th rank, what is the next rank, my dear students? 12th rank. So after 50, what is the number we have? 40. So this will be the 12th rank. So hope all the ranks that we have marked is clear for you people. So we'll take up the deviation. How to take up the deviation? R1 minus R2. So that is your rank 1 minus rank 2. So rank 1 minus rank 2, you'll get the deviation. So 1 minus 5.5, minus 4.5. Similarly, you will do it for all the data and you take up the d square. From that, the summation of d square will be 198. So let's substitute that to the formula. Substituting these values, 1 minus 6. What is sigma d square? 198 plus, what is your m1? M1 is how much? M1 is 2 times repetitive. So how many numbers we have? 2 times. So how much you write? Your 2's cube minus 2 divided by 12 plus, again m2 is how much? Again m2 is also 2. 2 cube minus 2 divided by 12. Again we have how many numbers? M3 is here. So what is M3? 3 numbers we have. So 3 numbers, that is repetitive. 3 cube minus 3 divided by 12. So this is how you calculate. And the number of observation is how much? The number of observation is 1 to 12. So 12 square minus 12. So you can write this as 12 cube also. First take up the roots. So 2 into 2 into 2. 2 cube minus 2 divided by 12. Next 2 cube minus 2 divided by 12. Again next 3 cube minus 3 divided by 12. If you keep all the answer, add all the answer, multiply with 6 and then divide with this value and later you subtract with 1. The answer you get is what? 0.30 is the answer you get by solving this problem. Thus, there is a positive rank correlation between X and Y, and X and Y move in the same direction. However, the relationship cannot be described as strong. So, we have given the interpretation for the previous problem. So, this is the problem that I have given for you people. Test yourself. So, calculate the Spearman's rank correlation coefficient between X and Y and comment on their relationship. So, which kind of data? So, the data where ranks are not given. So, you have to assign the ranks and substitute the value. So, check whether any repetitive series is there. If the repetitive series is there, you have to substitute the another formula. Since it is not the repetitive problem, it is a ranks is not given, that is your case 2 problem. Solve it and check yourself. So conclusion for this chapter. So we have studied about the scatter diagram. So correlation is nothing but it explains the relationship between 2 or more variables. So in order to check out the relationship between 2 or more variables, we have a unit called correlation. So under correlation, to measure the relationship, we have 3 measuring tools, techniques and statistics. So one is scatter diagram, the other is correlation, and your last Karl Pearson's coefficient of correlation, and the last one is Spearman's rank correlation coefficient. So far we have discussed about the this chapter, so it is very important for you all. So that's it for today's class. Thank you so much for joining me. Stay fit, stay healthy. Smile is the biggest jewel you can wear. Keep smiling, people. Thank you.